Welcome back, Physics 30. So this is the FM2.7 section, solving problems with Newton's laws and free body diagrams. So taking a look at what we did in the last section there, where we introduced weight, Fg, and the normal force, and then applied that to various scenarios here. So draw accurate free body diagrams looking each forces acting upon an object or a system of objects, and then use those free body diagrams. So it's kind of steps to success. It always helps to draw a sketch. For one object, draw a free body diagram showing all the forces acting on it. Make the magnitudes and directions as accurate as you can. Label each force. If there are multiple objects, draw a separate diagram for each. And sometimes, yes, resolving a vector down into components, which we learned earlier. And apply Newton's second law to each component. So in other words, is there a net force being exerted on it? And then solve it. So let's look at this first example. Calculate the sum of the two forces exerted on the boat by workers A and B as seen in the figure below. So this is a bird's eye view. So we're looking down on the boat. So we're not going to have to worry about normal forces or FGs, just simply pulling the boat forward in two angled direction. So here we have person A pulling at an angle. So if we look at the boat going straight ahead, it's an angle of 45 in relationship to straight ahead. And over here, we have the person B pulling downwards. Now, in terms of direction conventions, we can just simply look at it in terms of, I don't know, we could call it the positive Y direction, the negative Y direction, the positive X direction, and the negative X direction. So we'll use that as a convention. All right? So if I look at person A, all right, and try to figure out what person A is doing. So pulling up at this angle here, all right, so pulling up like that, and we could break that down into a X movement and a Y movement. So we have this FA as being 40. Okay, so that's 40 newtons there. Hopefully I drew that big enough. Then we have an X direction and a Y direction. So we can break that down into those two directions. And of course, as luck would have it, this is a 45-degree angle. So we know that our force by person A in the X direction is going to be equal to the force applied by person A in the Y direction. Because it's 45 degrees, we're going to get both of them. So I'll call this the force of person A in the X direction, so FAX. And of course, that is the opposite side of the angle. And here's the hypotenuse. So sine of 45 is equal to the force of A in the X direction all over 40. All right. So if I solve for FAX, those are the facts. So 40 multiplied by sine of 45, that is going to give me 28.2843. And remember, with these, go about 4 decimal places. We don't want to round off too early. And my A is pulling to the right, so that is a positive movement. All right, so if I look at now my force of A in the Y direction, so I guess, let's see here. I guess I kind of screwed that up. This is actually FAY. Because opposite side is FAY. FAY. Good thing we caught that. Good thing we caught that. So, and it's also pulling up. And of course, upwards is the positive Y direction. So I apologize for that. Now, FAX, that is the adjacent side. So the side that makes up the triangle, that isn't the hypotenuse. So FAX, yes, that we're going to be figuring out with cos. So FAX all over 40. And then multiply each side by 40. And I'm going to get FAX equals 40 multiplied by the cos of 45. And for that, I get the same answer, 28.2843. So lucky for me, even though I made a mistake there and fixed it up, I'll get the same answer. So x is pulling to the right, positive x. Y is pulling up, positive y. So I have my two components for person A. Maybe I'll just do a line here. Now let's see here, the force exerted by person B, it's kind of downwards angled this way, right? So downwards that way. And let's see here, FB is equal to, let's see, 30 newtons. And the angle I'm given is in between here and the forward motion. So my X and my Y. My X and my Y. So I have the FBX, the force of person B in the X direction, and the force of person B in the Y direction. And this angle here, 37 degrees. All right, so what I'm going to do here, let's look at, so if I do the same thing here, it's whatever, it doesn't matter. So let's look at FBX. Hopefully this time I get it right. So FBX, the X is the adjacent side, so of course that's going to be cos. So cos of 37.0 is equal to FBX over the hypotenuse, 30. So of course multiply each side by 30, and I get FBX is equal to 23.9590 newtons. And since it's pulling to the right, that's positive X. Good. Now let's see if I can fit this on the edge here. I'm not sure if, hopefully you might have room here. So FB in the Y direction now. So of course that's the opposite side. Opposite deals with sine. So sine of 37 equals FB, can I squeeze it in? Y over 30. Just squeezed it in on the piece of paper. So multiply each side by 30. Multiplied by the sine of 37. FBY works out to be 18.0544 newtons. Now, Y is operating downwards, and downwards in our direction convention here is a negative Y, so I'm going to have to put a negative in front of there. Okay? Now, if you're running out of room here, I didn't leave a lot of room for this question, so if you want to do it on loose leaf, you certainly can. So now I need to find out what are all the X direction forces, and what are the sum of all the Y direction forces. So in my X direction, let's see what I got here. So I have this one right here, plus 28.2843, combined with 23.9590. And let's see here, that's going to give me a grand total of plus 52.2433 newtons. And then if I add in my Y's, so here's my Y here, it's a plus, again another plus 28.43. And my Y from over here, oh yeah, that was the negative 18. So 28 minus 18, 10.2299 is what I get. So with these, I can represent my triangle now. So my overall, I have my X and my Y for my overall force that gets being used over here. So I'll start off with this one, 52 in the positive X direction. So that is this. Don't worry about drawing the signs. The positive just tells me what direction to draw this arrow in. And then from there, 10.2299 newtons. So start to finish, so my overall vector is going to be looking like that. And you can see that this guy here is slightly stronger than this one, pulling at 40 versus 30. And of course we have that angle here, and we can call this F the resultant force. So the resultant force, and of course it's a squared plus b squared equals c squared, or in our case, fr squared. So what I could do is I could take the square root of that side automatically to get my answer. And let's see what else I got here. I got 10.2299 all squared. So if I work that out, I get 53.2 newtons. If I put that down to 3 sig figs. And of course what I got to do here, oh, I need the angle, right? So I have the opposite side, adjacent side. So tan of theta equals opposite side over adjacent side. So to figure out my theta, it's going to be the inverse tan of 10.2299 all over 52.2433. And I think when you work that out, you get 11.1 degrees. All right, so we have the magnitude. We almost have the direction. So let's work this now. So therefore, Fr is equal to 53.2 newtons. And for a direction, let's just say this is east and that's north. So it's east and then 11.1 degrees. And you can see it's going to be 11.1, right? Because this is a big force versus a force that's 1/5 of that. So east, then rotating it north. East, 11.1 degrees. North would be the final answer there. All right, so that's how you do that first one. Now, if you look at the assignment, question number 1 is like that. Okay, except if I'm looking at the boat question that I just did. So this could be very similar to the boat question, pulling to the right, down and up. It's just simply rotated this way. Okay, so we have positive y, negative y down, positive x, negative x. So you can make your two triangles like that. So it's just slightly tweaked. All right, so I'll leave you with that. And if you want to try number 1 in the assignment, you can certainly do that. All right, we'll see you again.